Welcome. Today we'll explore how to graph y equals 3 sine of x and understand its amplitude, period, and key features. Let's start by drawing our coordinate system. We'll need a larger y-axis range, since we're multiplying sine by 3. First, let's graph the standard sine function, y equals sine of x, in blue. This will help us understand how multiplying by 3 affects the graph. Now, let's see what happens when we multiply sine of x by 3. The new function, shown in red, has the same basic shape, but it's stretched vertically by a factor of 3. Let's understand the key features of this transformed sine function. The amplitude is the distance from the middle of the wave to either its maximum or minimum value. For y equals 3 sine x, the amplitude is 3. The period of the function remains unchanged at 2 pi. This is because multiplying sine by 3 only affects the vertical scaling, not the horizontal spacing. Let's identify some key points on our graph. The function equals 0 at the same x values as the original sine function, at x equals 0, pi, and 2 pi. The maximum value is positive 3, and the minimum value is negative 3. To summarize, when we multiply sine x by 3, we stretch the graph vertically by a factor of 3, changing the amplitude to 3, while keeping the period at 2 pi. The resulting function oscillates between positive 3 and negative 3. Thank you for watching. Practice graphing other transformed sine functions to better understand how different coefficients affect the graph.